Lesson 5.1, Solving Systems of Equations by Graphing. Before we can talk about how to solve a system of equations, it helps to understand what is a system of equations. Well, a system of equations is two or more equations. These are linear, that intersect and share a common solution. Now, the solution of the system of equations is the intersection. So these two things, the intersection and the solution, are the same. So one of the ways that we can solve a system of equations is by graphing the system. So when we solve systems, we have one method of graphing. We have another method of solving algebraically. Now, if we're solving algebraically, we can use substitution or elimination. And elimination has without multiplication and with multiplication. So we have a few different techniques that we can use. Now, solving a system of equations using graphing doesn't always give us an absolutely exact answer, because when we're graphing, the intersection may not be integers. And if the intersection is not integers, an integer coordinate, on the graph it won't line up exactly perfectly. So graphing is good when you only need to estimate the answer. Solving algebraically is good when you need an exact answer. Now, that's not to say that graphing won't give us an exact answer, it just won't always give us an exact answer. So in order to continue our discussion about what is a system of equations, an example of a system of equations could be y equals negative 4x plus 5, y equals 3x minus 9. That's one system. You could have something like 3x plus 5y equals 19 and 2x minus 6y equals negative 48. This could be another system. The lines will intersect at some point, and that will be the solution. So we're going to go through in this lesson and talk about solving systems of equations. We're going to start with graphing, and then we'll move on to solving algebraically. So let's start with graphing, and we'll start with our first example. We want to graph y equals negative 4x plus 5, y equals 3x minus 9. This is our system, and we want to find that solution. So first we're going to need to make a coordinate plane. Okay, so I have my coordinate plane. And I'm going to graph my first line. Now, our first step will be to put into y equals mx plus b form. Our second step will be to graph. And then our third step is to identify the intersection. Now, these two equations are already in y equals mx plus b format, so I don't have to convert those. So I find my b-intercept, which is 5. So 1, 2, 3, 4, 5. My slope is negative 4, which means I'll go down 4. 1, 2, 3, 4, and over 1. And just for accuracy, I'm going to go ahead and do that again. 1, 2, 3, 4, and over 1. Then I will connect my points. So here's my first equation. my second equation is y equals 3x minus 9. So I have to graph at negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. And then my slope is 3, which is the same as 3 over 1. So I'll go up 1, 2, 3, and over 1, 1, 2, 3, and over 1. And then I will graph that line. And my solution is the intersection, which is right here. Now in this case I did get an integer answer, but I may not always get an integer answer. But my solution is the point 1, 2, 1, 2, 3. So 2, negative 3. This point will give you a true answer if you plug it into both equations. And it is the only point that will give you a true answer if we plug it into both equations. So I just want to demonstrate that. If I plug in 2, negative 3, I get negative 3 is equal to negative 4 times 2 plus 5. So that's negative 3 is equal to negative 8 plus 5. That is true. If I plug it into my second, I get negative 3 is equal to 3 times 2 minus 9. Negative 3 is equal to 6 minus 9. That is true. Now let me pick any other point on this line. I'll pick the point 1, 1. If I plug it into my first equation, I get 1 is equal to negative 4 times 1 plus 5. That's true. But if I plug it into my second equation, 1 is equal to negative 6. That is not true. So you can see the only point that will give us a true answer is our intersection. So let's try one more of these with the equations already in y equals mx plus b format. So we'll do example 2. Y equals negative 3x plus 7. Y equals 2x minus 3. We'll make my graph. I start at 7. And my slope is negative 3, so I go down 3 and over 1. And I go ahead and connect those points. Here I start at negative 3, and my slope is 2, so I go up 2 over 1. And I connect those points. And my solution is this intersection. So my solution is 2, 1. Now, as I mentioned, it will not always be in y equals mx plus b format for you. So let's try one where it is not the case. So let's try this one. X plus 3y is equal to 6. X minus 3y is equal to 6. So my first step is going to be to put these into y equals mx plus b format. So I'll start with x plus 3y equals 6. I'll move my x over, so I'll have 3y is equal to negative x plus 6. I divide everything by 3, and I get y is equal to negative 1/3 x plus 2. Negative x over 3 is the same thing as negative 1/3 x, and I wrote it in this format so it would give us our slope. Then I'll convert the second equation. Move my x over, I get negative 3y is equal to negative x plus 6. Divide everything by negative 3, and I get y is equal to positive 1/3 x plus 2. So I'm going to graph this. I start at 2, and I go down 1 and over 3. Connect my lines, dots rather. I start at 2 again, and I go up 1 and over 3. And I can tell you right now where my intersection is, but I'll go ahead and draw the line. Here is my solution point. My solution is 0, 2, or the y-intercept. Now, as I had mentioned, they don't always give us an exact solution, so I want to try another problem that I'm just going to kind of make up off the top of my head and hope that it doesn't give me a good solution. We'll try 2x plus 3y equals 6 and 5x minus 4y equals negative 4. Okay, so first I'm going to convert each of these to y equals mx plus b. So I'll have 3y is equal to negative 2x plus 6. Divide everything by 3 and I get y is equal to negative 2/3 x plus 2. 5x minus 4y is equal to negative 4. So I have negative 4y is equal to negative 5x minus 4. Divide everything by negative 4. I get y is equal to 5/4 x plus 1. We'll see how well I do at picking and making up an example that don't go evenly. Okay, so for my first graph, I'll start at 2. My slope is negative 2/3, so I go down 2 and over 3, down 2 and over 3. So I will connect those dots. My next graph, I'm going to start at 1, and I'm going to go up 5. 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. And I'm going to connect those dots. Ah, I did a good job. Now, our solution still exists, but I don't have an integer solution. So at this point, what I'll say is I'll say the solution is approximately, well, this looks to be about 1.5, and this looks to be about 2 2/3. And that's the best guess I can make. I don't know this exact point, so I have to make a guess. And that is how you solve a system of equations by graphing.